In this video, we're going to look at creating toolpaths for the stool design that we laid out in the first part of this tutorial. I'm going to show you how you can choose the different sheets of material that we nested the parts onto and then assign the profile toolpath to those sheets. We're going to look at lots of different options within the profile toolpath, such as adjusting the pass depth and changing things like the ramping and the ordering of the toolpaths. In addition, we're going to show you how to do this when the material has been set up from the table surface or the base of the material, if you prefer to think of it in that way. So let's go ahead and start a new copy of the software. So let's click on the icon to open an existing file. From the project folder, we're going to choose the file 3legstoolvector.crv. And this is the file that we saved at the end of the companion tutorial to this, where we did the layout for this project. I'm going to click on the Open button, and when the file opens, you'll see that the data we've got is on sheets, and we'll show you how to use these sheets in a moment. The reason for this, if you haven't watched the first part of this tutorial, is the fact that we use the nesting function within the software in order to create multiple copies of our design and efficiently lay them out in our area of the material that we're going to cut. As the file's opened, we can see that we have the default sheet, which is essentially our work area. So if we needed to add to the design or create some new vectors, we could. In this case, we're ready to start doing our toolpathing, so what we need to do is choose the data that we'd like to bring into the current work area, and that's what the toolpaths will be assigned to. To do that, we can just double click on to the sheet we'd like to make current. So if I double click on this area here, you can see that this has now been brought into our main job setup area, and the default sheet is over here, which is this empty area that we could work in if we liked. I come over to the Toolpaths tab, so I'm going to come up and click on the icon here to switch to Toolpaths tab, which will also minimize the drawing tab on the left. So that will get smaller. On the right, the Toolpaths tab will get larger, and this will zoom in on our current sheet of material. It's worth noting at this point that if you do plan to cut this part, that it's extremely important that you use values in the toolpaths that are appropriate to your particular setup, material, machine and tooling. The first job before we calculate any toolpaths is to set up our material. So I'm going to come to the top of the Toolpaths tab, click on the Set button here. Here we're going to define the values that we're going to use in order to position our material on the CNC table and reference that. In this case, the part that we're cutting is going to be machined out of the material. So what's very important to us is that the tool is going to cut through the material. So there may be some benefit in this case, in order to avoid the fact that the material may not be a consistent thickness, of choosing the Z0 to be off the table rather than being off the top of the material. What's helpful about this is I know that if I'm reference off the top of the table when I set up my machine, that's going to be dead on 0, and so that if the tool is coming down to a value of 0, then that will be at that surface position. Whereas if I set from the top of the material and assume that my material is a constant thickness, but I had some areas that were a little bit thicker, then there would be some parts where I hadn't cut all the way through. This is a completely personal preference, and you should always choose whichever you're most comfortable with to work. In this case, we'll choose going off the table because it'll give us an opportunity to show how that type of setup could be used within the software. Now, working our way down the form, we're going to set the lower left-hand corner, where the red square is shown here, to be X, Y, 0. Check the rapid gaps above material. They're both reasonable, 0.2 inches above. The home start position is an absolute value, and now we're setting Z0 off the table. We have to remember the bottom of our block is 0, so the top of our block is at a height of plus 0.75. So this start position at the moment is inside the material. If we were to not notice that and hit OK, then the software will give us a warning and tell us that our current home Z position is too low. So if we hit OK, what it will do is automatically set that value so that it's at a safe height. If we go back into the material setup, click on Set, we can see the value it's assigned for that, If we wanted to, we could override that, put in our own value. I'm going to put in a value of Z1, so that's going to give us a 1/4 inch of clearance above the thickness of our material. So again, this is an absolute value, which is why you need to put a value of 1 in this case, because we've now got Z0 set to be off the table of the machine. So let's hit OK, and we now need to select the data that we'd like to machine, and we can go into the profile toolpath, which is this icon here. The start depth and cut depth are relative values based on the position of the top of our material. So in this case, the start depth is going to be 0 because we want to start at the top, and we want to cut all the way through. Now there's a variable we can use in a calculation within the form here to get the depth of our material if we can't remember the value. And so in here I could come in, I could type Z and hit the equals sign on the keyboard, and that will automatically fill in the value that's equivalent to the Z depth of our material. Next, we're going to come down and set the tool. I'm going to click on the select button, come into the tool database, and from under the Imperial end mill tools, we're going to choose 0.25 inch end mill, a 1/4 inch end mill, and hit OK. Now for this toolpath only, I'd like to override some of the parameters for that tool. So I'm going to click on the edit button, and I'm going to change the pass depth to be 0.25 of an inch. I'm happy that I can cut a 1/4 of an inch at a time through the material with this tool, at least for this toolpath based on the material I'm using. By hitting the edit button, it means I'll only override that for this toolpath and won't change those parameters forever in the tool database. Let's go ahead and hit OK. You may have noticed when we updated the pass depth there that the number of passes shown here where the cursor is updated from 6 to 3. And that's showing us that a pass depth of 0.25 of an inch will take 3 cuts to get all the way to our full cut depth of 0.75. Now, as well as editing that by changing the pass depth of the tool, I can also click on this button here to edit passes, and you can see there are other ways for me to change these values. Again, I could come down and specifically tell it to use the pass depth as we have here, or I could put in a specific number of passes. Maybe I could tell it that I wanted 5 passes, click the button to set passes, and it'll add those in evenly spaced. I could change that back to 3 and click on the button to set passes, and it'll go back to the values that we had before. Now, in addition to setting it in a way where the passes are equally spaced, I can also come in and specifically edit the value of the passes or add additional passes in here. In this case, what I'd like to do is show you how we could add a thinner last pass thickness. So that will mean that we'll go from 3 to 4 passes, but it gives me the ability to set a very thin final cut for my final pass, so that it's having to do less work and hopefully will give me a better edge finish. So here I can click on the checkbox to set last pass thickness, and we'll put in a last pass thickness of maybe 50 thousandths of an inch, 0.05 of an inch, hit apply, and you'll see that's added an additional pass in here, showing me that last pass thickness with this darker orange, and now I've got this extra pass at 0.7 inches from the top of my material. So I'm going to go ahead and hit OK. It's now showing me I've got 4 passes to cut through this. Now in this case, we want to cut out all the vectors that we've got selected. What that means is we need the tool geometry to go completely on the outside of each of these parts, but then when it finds one of the holes for our mortise, then it's going to cut completely inside that part. Now the way that all the Vectric software works is when we choose the option to machine vectors here, what we're doing is choosing the first, or what's going to happen to the first vector that we come to. So in this case, we're going to cut outside the first vector. That means that the software will automatically then alternate when it finds vectors within that to cut inside of those. And if we had a design where we had parts within parts, then it would know to cut outside, inside, outside, inside. So we're always going to get the tool on the right side of our vectors in order to create the parts we need. So here under machine vectors, we're going to make sure we have outside selected. Now for this job, I think I would like to add some ramping to it to relieve some of the pressure on the tool having to go straight vertically into the material. So I'm going to come down and choose the option for ramps. I'm going to say add ramps to the toolpath. We have the choice of doing smooth ramps so that it smoothly blends down and in, zigzag, or a spiral ramp. In this case I'm going to do a smooth ramp so it flows down and into the part, and I'm just going to add a short ramp of 1 inch to each of the passes that we're going to take for this particular job. Next we can specify the name, and in this case, if you remember, we're working with the vectors from sheet 1. So what I'm going to do is change the name so that it's called Profile Sheet 1, and that way I'll know when I look at the toolpaths in the toolpath list that this toolpath is specific to the vectors on sheet 1, and that'll help me when I come to save the toolpaths to make sure I identify the right one. Let's go ahead now and hit calculate and look at some of the things we've chosen. Once we've calculated the toolpath, the software will automatically open the Preview Toolpaths form so that we can see a virtual preview of our toolpath rendered in the material. Before we go ahead and look at that, let's zoom in on the toolpath itself in the 3D view here. We can see, if we look at one of the edges, how our tool is ramping into each of the profile cuts. So we talked about the fact we added the ramping there, means it's coming down and then ramping its way in, which is just going to relieve some of the pressure on the tool, stopping it from having to vertically plunge into the material. So let's go up to an ISO view now, and we'll choose a different coloured material to preview this in. I'm going to click on the drop down list and we'll come up towards the top here and choose Canadian Maple. That's a little more of a kind of a typical plywood colour there. And next we can choose some options here for looking at how this toolpath is going to cut. We can click on the option to animate the preview and draw the tool if we want. We could play this. Before we play it, we may want to make it run a little slower so we can really watch it and see what's happening. So we'll pull the slider down to the left to slow this down, hit play, and we can see then how that tool is going to go around and cut that out. We could slow that down even more if we wanted to, and watch the preview and get a really good idea of the way these parts are being cut out. Now notice how the software automatically knows to cut those internal shapes first, because you don't want the part being cut out before those shapes have been machined away. So that's now complete, and we can see our 3D preview there. So if we're happy with that, we can hit close on the preview form, and we'll go back to the Toolpath tab. And now we're ready to look at the data for our second sheet of material. So we need to go back to the 2D view. We can come over and click on the tab here so we can see what's happening there. And if we wanted to, we could actually see both views at once. If we come up to View, Tile Windows Horizontal, it's going to show us the 2D view at the top and the 3D view at the bottom. What I want to do now is select the data for sheet 2. So I can do this by double clicking on the sheet itself, and now you can see that data has been moved into the current work area. Next, I want to calculate the toolpath on that data based on the same parameters that I used for sheet 1. So the best way to do that is to take the toolpath for sheet 1 and to click on the icon to copy it. When we click on that, we're going to create a new toolpath with the same name with the added parentheses of 1 in there. Now what I can do is double click on that. I can select the new data that I'd like to machine with it. I'm going to change the name to Profile Sheet 2 so that we know that this is going to machine the data for Sheet 2. And this is going to apply exactly the same parameters that I had for Sheet 1. That includes cut depth, the extra pass that I added, the ramping that we activated. So if we hit calculate now, we'll see that toolpath calculated in the 3D view. If I want to preview that, I can maximize the 3D view, and you can see that before we preview this we need to reset it from the preview of our original sheet. So let's click on the button to reset preview. We can go ahead now and click on the button to preview selected toolpath. You can see which one's selected because it's bold in the list down the bottom here. So we'll click that, and there we can see that being animated again. If we wanted to speed it up, we can, right to the point of it running through as fast as it is possible. Now if we were happy with that at this point, we could close the preview and we could go ahead and output each of those sheets as a separate toolpath and run them in separate sheets of material. Take profile sheet 1, click Save Toolpath, choose an appropriate post-processor, hit Save Toolpath and save that file, and then we'd choose sheet 2, save Toolpath and save that file and give it an appropriate name as well so we knew what it was intended to cut. And they'd be ready to transfer to your CNC machine and to cut those files out. So before we conclude this tutorial, I'd like to show you another option that we have with the profile toolpaths. Let's imagine in our scenario that after we cut our parts, we realise that it would be beneficial to us if we could change the order that they would cut. Perhaps we have a vacuum system that would benefit from us cutting the parts furthest away from this side of the machine and then working back towards this side and keeping the strongest pull of the vacuum as we cut out the parts and release some of the vacuum pressure. Let's show you how we could achieve that. So hit close on the Save Toolpaths form. Let's come back into the 2D view. And then making sure we still have the right sheet in our current work area, let's double click on the toolpath for profile sheet 2. This will allow us to edit it. If I close this, another way we can get to the edit function is to select it and choose this icon here. So either the double click or this icon will do the same thing. It will select the data that we calculated this toolpath on originally, and it will open the form and allow us to make edits to it. We can change the order that the toolpath is calculated by coming over here and clicking on this tab to adjust the order or to tell the software the way that we would like the order to be calculated. There are various options that we can use in here, and you can see the settings that we had for the first time we calculated this toolpath. In this case, what I'd like to do is uncheck these and choose the option for vector selection order. Then what I'm going to do is just click to deselect the vectors, and then I'm going to go in and select the order that I would like them cut. First off, I would like to cut these 4 shapes for the base shapes here, which are furthest away from our left hand end. Then I'm going to hold the Shift key down on the keyboard and click each of the vectors in the order that I would like them to be cut out. So I'm just working my way back towards the lower left hand corner. So it should cut these 4 shapes first and then work back in kind of an S pattern all the way back to the lower left hand corner here. If I hit calculate, we may see that reflected in the lead, so we can see this going over to here, and then these are moving between these 4 before working their way back. Sometimes it's not always easy to see that based on the leads, so another way we can look at it is in the preview toolpaths we can step through to each retract. So if I do this, I can click here, and what we'll need to do is actually stop that for a second, reset the preview so we can see this actually happening, and then I'm going to click here to run to retract, and you can see that cutting the first of our internal shapes here. So if I just click my way through, it's going to cut in order, so I'm just clicking so we can see it cutting those 4 shapes first. If I really wanted to affect the order that it cut those 4 shapes, I could have individually selected those vectors in order as well. Now we should see it stepping back in the pattern that we selected them from the 2D view and cutting in exactly the order that we want, and we've been able to preview that before we go out and cut this on the machine. So again, if we wanted to change our toolpath now, I would go ahead and close this, and I would save my new toolpath, and that's the toolpath I would run that would have this new toolpath ordering in it. So we can close our Save Toolpaths form now, and let's actually save the whole file in the project folder. So I'll come up to File, Save As, and I'm going to call this 3-leg stool-TP for toolpath. Hit save so that we have that file there if you want to take a look at it. So to summarize, in this tutorial we took in the vectors that we'd laid out in the companion tutorial to this for the design of our 3-legged stool nested over 2 sheets of material. We showed you how you'd set up the material if you wanted to, in this case by putting Z0 on the bed of the machine. And then we looked at the profile toolpath and some of the options within it. We saw how we could apply different pass steps based on whether we chose a depth of cut for the tool or whether we went in and manually edited those pass steps. We also looked at how we could apply things like ramping to the toolpaths, and then ultimately how we could adjust things like the ordering for the toolpaths as well. That concludes this presentation.